hypothesis test for a population proportion. Example number 1, testing a hypothesis about a population proportion. This is a large sample. Remember, when my sample is large, we can use the normal distribution to solve this problem. In 1997, 46% of Americans said they did not trust the media when it comes to reporting the news fully, accurately, and fairly. In 2007, poll of 1,010 adults nationwide, 525 stated they did not trust the media. At the alpha confidence level, 0.05, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurate has increased since 1997? I am going to do this problem using logical reasoning step by step. Also, I am going to do the same problem using technology. I will input the data in StatCrunch and I will obtain all answers. You will be allowed during the test, the Proctor test, to use technology, StatCrunch, Excel, or whatever statistical software, but you will be requested to show your work, to show logical steps. The objective of this course is that you must be above the machine. You will understand what the machine is doing to solve the problem for you. Remember, the machine uses artificial intelligence. You have natural intelligence. Pay attention that we have a previous study, or we have a reference value for the parameter. In this case, our parameter is proportion. Then let's start. Let's follow the all 5 steps that we studied in the previous section. So we have a population. In this population, the previous study stated that the population proportion was 46%. But that was in 1997. Right now, we are going to take a sample, 2007, approximately 10 years later, and we are going to compute in this sample my sample proportion. And we are going to use this evidence to support or reject this assumption. First of all, let's determine which one is the purpose of this researcher. What is the suspicion of this researcher? What is the statement that this researcher wants to prove? You need to find the word claim, and close to this claim you can find the purpose. Listen, is there at alpha 0.05 significant level, is there evidence to support the claim? Which claim? That the percentage of Americans that do not trust the media has increased. My claim is the percentage has increased since 1997. In 1997 was 46%, but right now this researcher states that increases. My first step is determine the null and the alternative. Almost always the claim is located in the alternative hypothesis. Almost always, not all. In some cases, the claim is located in the null hypothesis. But remember, the null hypothesis always include the equal. Is the statement about the previous study. We respect this previous study. We are going to assume that the proportion of the population is 46%, as it was in 1997. And the alternative hypothesis is my suspicion. The alternative hypothesis is the proportion is greater. Actually, these two statements are opposite. My second step, determine which one is alpha, my significant level. The significant level was 5%. Alpha is 0.05. And the requirement, because this is a large sample, we are going to use the normal distribution model. To use this mathematical model, we need to verify that my sample is big enough. And first of all, it's a simple random sample. Let's assume that was a simple random sample. And big enough, we need to do this calculation, NPQ. N is 1010, the sample size, 46% is the assumption that the proportion is this, and the complement is Q, 1 minus P. When we multiply all of these, we can observe that this is greater than 10. Then this sample actually is very big. is big. My third condition is my sample is not too big. Actually, it's less than 5% of the population, and that guarantee the independence of my selection. Then we can use a normal distribution. Third step. What is the third step? We need to collect, to transform all the evidence that I have in this sample and transform this evidence in one score. In this case, because we are using normal distribution, we need to transform all of this evidence in z-score. Then my evidence, what is my evidence? In my sample of 1010 people, 525, they don't trust in medias. Then from this 1010, 525 didn't trust in the media to report accurately the news. And that is my evidence. I need to transform this evidence in z-score. Why z-score? I want to know how far away this evidence is from my expectation. Remember, in the center we have the true parameter. And in this case, let's assume that the true parameter is 46%. My evidence is 52%. 52% of all citizens didn't trust the media. Then let's transform this in z-score. How far away is my evidence from the center? Is 0.52 minus 0.46, because we assume that this is the true parameter. And the standard deviation of the distribution is given by this. Remember, square root of PQ divided by N. We use this value to compute standard deviation. Then this value is 3.83. That is my evidence. We know that the distribution for all sample proportion follow a normal distribution. The true parameter, let's assume that is 0.46, and we obtain 0.53, and this value is located approximately 4 standard deviation from the center to the right. That is my evidence. Next step is the step number 4. If we want to use the classical approach, we need to find critical values to compare my evidence transformed in z-score with this critical value. How can we do that? To obtain the critical value, the most important information is alpha. Alpha is 0.05. And also the distribution, in this case, is a normal distribution, and the kind of test. Remember, the kind of test depends on my alternative hypothesis. In this case, the alternative hypothesis states that the proportion is greater than 0.46. This test is a Reitel test because we expect that the proportion is greater. Then, because it's a Reitel test, we need only one critical value located on the right. We can obtain this critical value very easy in StatCrunch. We can go to StatCrunch, we have to go to Stat, Calculator, Normal Distribution, and select a standard because it's only one tail, and input 0 for the mean and 1 for the standard deviation. This is equivalent to the table when the mean is 0 and the standard deviation is 1. Then we need to select here greater than, and we have to input 0.05 in this box. After that, click compute, and we obtain 1.645. And that is the value, that is the critical value. This is my critical value. Then if I obtain an example to the right of this value, we are going to reject the null hypothesis. This is the rejection region. The true parameter is located here. This is StatCrunch, but you must show your work using formulas and table. How can we obtain the same critical value, 1.645, using table? To obtain the z-score for this value, we need to know what is the area to the left of this value. If the area to the right is 5%, the area to the left is 95%. And we can write this in this way, 0.9500, okay? That is the value that we need to find in the table, because the table works only with probability to the left. But this value is not in the table, it's between this and this. But it's exactly in the middle, exactly in the middle. Then the corresponding z-score for this value is 1.64. And the corresponding z-score for the other value is 1.65. Because this value is exactly in the middle, we need to add 1.64 plus 1.65 and divided by 2. That is exactly this value that we obtained in StatCrunch, 1.645, rounding the third decimal. Okay, we found the critical value. My evidence falls here. What is my evidence? My evidence is the C-score of my sample. Remember, my sample was 53%. We obtained the C-score, fall 3.83 standard deviation to the right. Because fall in the rejection region, then my conclusion should be we reject the assumption that the true proportion is located here. Why? Because we work with this confidence level 5%. Suppose that we have 100 samples. Between these 100 samples, we have 5 here and 95 here. If you select one sample randomly, from which of these two groups do you expect to select one sample? Obvious, from this group. That is the reason we expect to select one sample from this group, not from this group. Okay? The probability to select one of these is too small. We reject the assumption, the null hypothesis. And we support the alternative hypothesis, which states that the true parameter or the center of the distribution is shifted to the right. The true parameter is bigger than 46%. That is the logical explanation to get a value in this region, that the distribution is shifted to the right. The p-value approach, you can use either p-value or critical value. You have to do only one, but if you do both, it's okay. If you use any of these two procedures, you must reach the same conclusion. What is the p-value procedure? You don't have to obtain in p-value critical value. You need to obtain the p-value of your evidence. Then the most important information to obtain the p-value is your evidence, my sample statistic. That is my evidence. My evidence was condensed in this score. Remember that? Okay. And also we need the distribution, which is normal distribution, and kind of test. Why kind of test? Because if it's a right-tail test, the p-value is the probability to the right of my evidence. This is the p-value, probability to obtain one sample with a C-score greater than 3.83. That is the distribution. I know that the true proportion is in the middle, and 3.83 is located here approximately. Yeah. Then what is the probability to get this value or one value more extreme? In StatCrunch is very easy. The only thing that you have to do is to select standard, is only one side, greater, and input 3.83 here and click compute. What is the probability? 0.00006. If you need to round this to 3 decimal, we round this to 0. Okay, the probability is 0. The probability to get this value is 0. Can you see? It's consistent with the previous result. What is the probability to get one value far away from the center is 0 in that distribution. Then let's reject the assumption that the center is not there. The center should be shifted to the right. How can we show our work using table? We need to find the area to the right of this value, because this is a positive C-score. We use the positive C-score table. In this table, we need to find 3.83, but this value, this C-score is not in the table because the maximum value in the table here is 3.4 and here is 3.49. Actually, the maximum value is 3.49 and the value located here in the positive C-score table is 0.9998. But what does this area represent? Represent probability to the left. Then 99.99% of all samples are located to the left. Then what is the probability that one sample is located to the right? Is the complement. 1 minus this is 0.002. But that is not the p-value that we want to find, because this is the p-value of 3.49, but the p-value that we want to find is 3.83, is to the right. Then the p-value, the probability to the right should be smaller than this. Then the probability is less than 0.002. Then, because it's less than 0.002, if we compare this probability with alpha is 0.05, we conclude that is smaller. If the p-value is smaller than alpha, is because my evidence falls far away from the center, Then we reject the null hypothesis. Then in the last step, we write the conclusion. you must go back to review what is the objective of this study, which is the claim. The claim was the proportion is greater than 46. In the null hypothesis, we state that the proportion have not changed since 1997. The alternative contains the suspicion of the researcher that the proportion has increased since 1997, is greater than 46%. In the conclusion, you must reject or support the claim. If the claim is the null hypothesis, you reject. But if your claim is the alternative hypothesis, you support. On the other hand, if your evidence falls in the rejection region, in this area, you have sufficient evidence or enough evidence either to reject or to support. However, if you got a value close to the previous study, then you have insufficient evidence either to reject or to support. In this example, because my claim is in the alternative, we support the claim because we have sufficient evidence. And my conclusion could be written in this way. There is sufficient evidence at the alpha 0.05 level of significance to conclude that the percentage of Americans that do not trust the media to report fully and accurately has increased since 1997. We have found evidence in this study to support this statement. We can do this problem in StatCrunch in seconds. In StatCrunch, go to Stat, Proportion, Stats, one sample, because in Statistic 2 we deal with two populations, but here only one population, and the problem gives us the summary, not the data one by one. Then we select summary, and here we need to input the number of success. In this case, 525 people do not trust the media among 1010 people, which was my sample size. In StatCrunch, we can construct confidence interval or we can test hypothesis. Here we need to enter the null hypothesis. The null hypothesis in this case was the previous study, which stated that the proportion is 46%, and the researchers suspect that is greater than 46%, and we click compute, and that's it. We have all answers. We have sample proportion, which was 0.5198. When we round it, is 0.52. The test statistic is the z-score, which is 3.813. This value here is the standard error, which is the standard deviation in this denominator. And here we have the p-value, probability value, probability to get this evidence or one evidence more extreme. We obtain this p-value using table, the positive z-score table, which is this one. To find the p-value of this test statistic 3.81, then we need to go to 3 point here. The maximum value that appear in this table is 3.49. Then that is the probability to the left of this z-score. 3.49 is approximately here. Then the probability to the left, or the area to the left of 3.49 is 0.998. The probability to the left for 3.80 should be bigger than this number, should be 0.9999, something like this. Since p-value is probability to the right in this case, because we are doing a right tail test, then the p-value is 1 minus this quantity, then is approximately 0.001. We obtain this p-value, we obtain the p-value with this reasoning. Actually, we verify with the reasoning that the p-value of my evidence is smaller than alpha. It's obvious that this p-value given in StatCrunch is smaller than alpha. 0.001 is smaller than 0.05. Then it's very easy to obtain all answers in StatCrunch.